Calculate the standard cell potential produced by a voltaic cell consisting of a gold electrode in contact with a solution of gold ions and a silver electrode in contact with solution of silver ions. So in one side we are dealing with gold, in one side we are dealing with silver. Interesting. First of all, we need to write down the two half reactions, one for gold, one for silver. Au in ionic form, 3 plus 3 electrons is going to give us gold in solid phase. On the other hand, we have Ag plus 1 electron is going to give us solid silver. These two have reaction, both of them in reduction form. In order to find out the standard reduction potential, we need to go and find a table called standard reduction potential. For Au, that's going to be 1.5 volt. For silver is going to be 0.8 volt. Now we need to figure out which one is anode, which one is cathode. Cathode is where reduction happens, and anode is where oxidation happens. Reduction happens where we are dealing with a stronger oxidizing agent. How do we figure out which one is stronger oxidizing agent? We need to look for these two numbers. Whatever has a greater value for standard reduction potential, it is going to be more stronger oxidizing agent. So in this case, we have 1.5 versus 0.8. So since this one is greater, we're going to say this one is stronger oxidizing agent comparing to silver. So gold is going to be the cathode, and silver is going to be the anode because it has a smaller number. And if you want to find out the standard cell potential, we use this formula. Standard cell potential equals to, my pen just died. It's going to be standard reduction potential of cathode minus standard reduction potential of the anode. Cathode is going to be gold, which is 1.5 minus 0.8, which is going to give us 0.7 volt. That's the standard cell potential produced by these two electrodes.